All right, guys, this is Algebra 2, and this is day 1 of 2.2.1. So we're going to be talking about transformations of functions here. So to start off, this is going to be fairly exploratory, so I want you to open up Desmos for me. And then you're going to choose one of these functions of these families of functions. We have the cubics, the rationals, the square roots, the absolute values, or the exponentials. And if you want to do exponential, use a b-value of 2. So choose one of those and try and figure out how you can do the following. How can you move the function left, or sorry, move it up, move it, move it left, move it right, move it up, move it down, and how can you cause it to stretch vertically, how can you cause it to compress vertically, and how can you cause it to be flipped over. Try to figure out how you can have all of those things happen. So you want to get to the point where I could say, hey, move it left 2, up 3, and flip it over, and you can type it in and it'll do exactly what we want it to be doing. So try to figure out how you can do all of those things. Once you've done it with one of those families of functions, I'm going to ask you to do it with a second one as well. Now, I will tell you the same rules should apply, so try and use the exact same knowledge and rules you just used on the first one and see if it still works on that second one. It should, so long as you're doing it correctly. So go ahead and pause and try that out and then come back here. Okay, so let's take a look at Desmos here. So I'm going to pull this up and I'm going to graph, we'll do x to the third power first. So if I want this to be shifted around, I'm going to put x to the third power in parentheses. And if I want to move it up and down, plus 2 is going to move it up 2, minus 3 is going to move it down 3, stuff like that. So any time that I add to the end or subtract from the end of the base function, that's what causes those vertical shifts, right? So then if I want a horizontal shift, so left or right, I don't put it there, I actually put it on the inside, attached to that x. So that's like our minus h thing, right? So if I put a minus 5 here, I go right 5. If I put a plus 4, I go left 4. So it's going to be the opposite of what you would naturally think, but on the inside there, that's how I go left and right. And then to vertically expand it or to vertically stretch it, if I put a 2 here, everything gets stretched vertically to be double the heights. And if I put a 0.5 here, it's going to be compressed vertically, so it's now half as tall as it was. And then finally for a flip, I throw a negative there and it gives me that flip vertically. So what if I said I want it to be 3 times as tall? I want it to be moved right 4 and then down 5. So I want 3 times as tall. I want right 4, so minus 4 there, and I want it to be down 5, so I'm going to put a minus 5 on the end, and there it is. Okay, we want you to get to a point where it's that easy. You can just say, well, here's what each of these parts mean. Here's what the graph should look like. Right. Now let's try this out for a different function family. Let's do the square root of x. Oops. There we go. Okay. So if I go down here, if I want this to move up 5, well, again, I put plus 5 on the end of it, and now it hits up 5. What if I want it to move down 3? Well, minus 3 on the end, hey, move down 3. Also, it's the exact same thing as the last one was. So if I want it to move left and right, I have to add or subtract, but attached to that x. So you want it as close to the x as you can possibly get it. So that means I have to go inside of my radical here and put, say, minus 8. Hey, now I moved to the right 8. If I want to put like a plus 2, I moved left 2. So it's doing the exact same thing as the other ones, but on square root functions now. What if I put if I put a 2 out front, it should double the heights, right? Boom, it does exactly that, right? All my y values have been doubled. It's now twice the heights which it was. If I put like a 0.25, it's now a quarter of the heights of everything as I go across. So it's doing that. And if I put a negative, it should flip it. There it does. It does exactly that. So these are our kind of rules which we have discovered kind of doing this. So let's hop back over here. Oops, wrong. There we go. All right. So that's what we want to do today. We explored it. As long as you kind of saw those, we are good, right? So just try and, in your mind now, generalize what were those rules, how could I cause each of those things to happen? And that's all we really need for today. So we're going to do part 2 of this next time. Here is the homework for day 1, 81 through 87, and I will talk to you guys next time.